Hello students, welcome back. So in this session, we are going to be learning variance and standard deviation. This is part of your descriptive statistics. First thing we do, import your NumPy as NP. All right. And let's create some data. So let's say this is my data, 2, 5, 7, 5, 6. This is the numbers right here. And I want to calculate the mean, variance, and standard deviation. So there is an inbuilt method inside NP. You can use mean, and you can pass your data inside. Same thing with variance. There's a var. Var is a short for variance, and inside this method, pass your data, and then you have .std. std is a short for standard deviation, and pass your data to it. And when you run this, that's going to print out your mean value, your variance, and your standard deviation right here. So, in case if you do not know how you calculate mean, variance, and standard deviation, I'll just show you real quick. So, the way you calculate mean is basically you just say x equal to 2 plus 5 plus you basically taking all the numbers, okay, and you just add them all together, and then all the way up to 6. You add them all together, and then you divide by the total count. How many numbers you have over here? Total 5 numbers. So the answer was going to be 5. And this is how you get mean. Variance, on the other hand, uh, variance on the other hand is calculated a little differently. So for the formula for variance is sigma square, and the formula is like this. You say xi, basically x is gonna you're gonna iterate over each xi and your x mean, and then you square each one of the elements, and you divide by the total count. Okay, so in this case, this is gonna be equal to your 2 minus 5 because that's my main value, right? This is my main plus, then you have, I done with 2, then you start with 5. You say 5 minus 5 square, all right? Then you have 7, then you say plus 7 minus 5, and then square, 7 is done, and then you got another 5 plus 5 minus 5 square, and then you got the 6 plus 6 minus 5 square. And then you divide the whole thing by 5 because that's the number of points you got. Now, when you solve this thing, you will get an answer as 2.8. So this is your variance 2.8. And this is how you get 2.8. Your standard deviation, on the other hand, is a square root of your variance. So standard deviation, generally denoted by sigma, is equal to square root of variance. So in this case, under root of 2.8, and that will give you this answer right here. Okay, so this is how you calculate your variance and standard deviation. Now let's dive a little bit deeper into variance and standard deviation through some examples. So let's say I have this data, and in data 1 you can see all numbers are 5, 5, 5, 5. All of them are 5. In data number 2, I have different set of numbers. Look at this, 4, 3, 5, 6, 7. So the data is varying a little bit. In this case, there is no variance happening over. There is no variation happening in your data. In the second one, in data 2, you see some variance happening over here. On the other hand, look at the data 3, 1, 1, 0, 0, 5, 9, 9, 10, 10, 5. So you can see there is some variation in your data over here. So let's try to calculate the variance for each one of them. And so I'm just calculating variance for my data 1, which is right here, and I'm printing my variance for data 1. Then I'm doing the same thing for my data 2 right here, and then data 3. And then as you can see, for your data first, which is all the numbers are 5, your variance is 0. That makes sense because all numbers are same. So because all numbers are same, there is no variability or there is no variation in your data. So it's coming out to be 0. Let's look at this one right here. You can see there is some variation in your data, and because there's some variability in your data, you have some finite number. It's very tiny, not a big, but still you see some variation in your data. So this is why that's why you're seeing some variation. Now look at this one. You have a little bit more higher variability in your data. That's why your variation in this case is 16.4. So you're going from 0 to 1.5 to 16.4 because the variation in your data is increasing. So variance actually measures how much spread there is in your data from its mean value. And standard deviation, by the way, does the same thing. It just scales it down a little bit and converts this back into its unit. Okay, thank you.